All right, so we are doing the 7.1 and 7.2 notes here for geometry. We got ratios and proportions and similar polygons. This is going to be part one. So quick warm up here. You may not be ready to solve this one right this moment, but if you are, feel free to pause this and solve these proportions. All right, so let's go ahead and work through them. So cross products property is the best way to solve these proportions. You're gonna multiply here, you can multiply diagonally. We'll talk more about this later on in here, but the cross products property is a great way to solve proportions. So in this case, be careful, make sure that you are distributing when you do this one. 9 times this whole thing is equal to 12 times 6. Let's go ahead and distribute that one in there. 9 times 2x is going to be 18x, minus 9 times 1 is 9, and 12 times 6 is 72. Once we do that, we have a pretty simple equation left here, kind of a two-step equation. So we'll add 9 to both sides, end up with 18x equals 81. Divide by 18, divide by 18, and we are going to get x is equal to, I believe it's 4.5 here, but let me just double check this. 4.5. You could go ahead and substitute that back in there and make sure that works out. I believe that it does, though. And then let's go ahead and go after the second one here real quick. Again, feel free to pause it and try it on your own, but I'm going to go ahead and move forward. So cross products here, we have 10 times 15 minus x. It doesn't really matter which side each of these products goes on, just one on one side and one on the other side of our equation. All right, then we need to distribute this. We have 150 minus 10x equals 18x minus 18. A little bit more complicated equation than this one over here. Once we get done with that cross products, we have x's on both sides. I'm just going to get rid of this x over here by adding 10x. That's going to give us 150 is equal to 28x minus 18. And then we just finish this off, add 18 to both sides. That's 168 equals 28x and divide by 28. So 168 divided by 28 is 6. So x is equal to 6. Again, we can check this solution. We can substitute in here. Let's go ahead and do that really quickly on this one. So 6 minus 1 is 5, so we get 10 over 5. And then over here we have 15 minus 6 is 9, so we get 18 over 9. Hopefully you can see both of these are actually just equal to 2. So these are equal ratios when we substitute that value in for x, so that is a proper solution there. Let me go ahead and clear this and kind of move forward into our lesson for today. So we're going to be focusing first on the 7.1 ratios and proportions. Funny little comic here for you if you want to pause and read that. Okay. So ratios and proportions. This is going to be a bit of a review of the stuff that we spoke about last week, but a ratio is a comparison of two quantities. What I mean by a comparison is we can write it out either as a fraction. So you'll often see ratios written as A over B, or we may also write it as A colon B or A to B. Another thing with this is usually these ratios are simplified. We divide out any common factors, but not always. Sometimes they're just left in their unsimplified form. Quick question here. What is the ratio of circles to squares? Okay, easy enough. We have 1, 2, 3 circles to 1, 2, 3, 4, 5, 6 to 6 squares. So 3 circles to 6 squares. Again, we could reduce this. I like writing my ratios as fractions. That's going to be the most common way to do it, but I could have also done it this way or this way. And then I can also reduce this. All of these ratios do reduce. We have a common factor of 3, so we can divide both of these by 3. And our simplified ratio is 1 to 2. That's telling me there is one circle for every 2 squares. So 1 circle for every 2 squares. 1 circle for every 2 squares, and then last circle, last 2 squares. So yeah, every 1 circle can be paired up with 2 squares. That's a ratio. Next thing, proportion. So a proportion is a way for us to talk about 2 ratios or more ratios being equal to each other. A proportion is simply an equation that says we have 2 equal ratios. So A over B equals C over D. That's an example of a proportion. We're saying that these ratios are equal. Let's go ahead and solve this problem. The word proportional, this is the way we describe relationships. Sometimes we say things are proportional. That means the ratios that we create will be equal to each other. They will all simplify to be the same thing. Okay, so let's go ahead and look at this here. The amount of flour in a cookie recipe is proportional to the amount of cookies that are made. 2 cups of flour make 24 cookies. How much flour is needed to make 150 cookies? So we are saying that flour is proportional to cookies. So when I write these ratios, flours over cookies or cookies over flour, either way, I need to be consistent. I need to pick one of these. All my ratios will be equal. That makes it, this always works in recipes. You know, if you double a recipe, you double all the ingredients. So that's kind of always true when we're talking about these things in terms of recipes. But let's go ahead and set up a proportion that allows us to solve this problem. So it says that it takes 2 cups of flour, so 2 cups of flour to make 24 cookies. We know that this is proportional. It's an equal ratio to this other situation. We want to know how many cups of flour will it take to make 150 cookies. If these things are indeed proportional, amount of flour and cookies, then these 2 ratios have to be equal to each other. You don't need to write the units, you don't need to write cups and cookies and things, but you do need to make sure you set this up with consistency. I chose to put cups on top of my ratios, so the amount of flour on the top, and then in both of these ratios, put cookies on the bottom. If I start switching these up and mixing and matching, I may not get the right setup. I have to make sure I do it with consistency. So whatever I put on top in one ratio, I need to put a corresponding thing on top in the other ratio. So flour and flour, for instance. Same thing in the denominator here, cookies and cookies. Anyway, let's go ahead and solve this proportion. I'm going to ignore the words here. I'm going to solve it by doing cross multiplying. I have 24 times x equals 2 times 150, which is 300, and then I divide by 24. So I end up getting x is equal to 300 divided by 24, which is 12.5 or 12.5 cups of flour is needed to make 150 cookies. All right. Here we're going to go a little bit more in depth with the cross products property. So cross products property is what we were doing for us to solve proportions. Basically means if you have a proportion, 2 equal ratios, A over B equals C over D, it says that these products, when you multiply diagonally, A times D diagonally is going to equal C times B or B times C. Always true as long as you have equal ratios. Why does that work? Let's just kind of quickly illustrate why that works. It's nothing fancy. Really, all we're doing is applying some properties of equality that we actually already know about. So I can show that this is equivalent to AD equals BC. I can show that these things are equivalent. All I need to do is take some steps, take some valid mathematical steps. So I can multiply both sides of this equation by BD. That's using the multiplication property. I'm just multiplying 2 sides of an equation by the same thing. So that's certainly allowed. That's going to give me A, B, D over B equals C, B, D over D. And now I can go ahead and use my division property to divide some of these, or sorry, I can just simply simplify what I have here a little bit. I have a b on the top and the bottom of my fraction. B divided by b is 1. D divided by d is also 1. Those things can cancel out, so to speak, leaving us with a times d equals c times b. C times b can just be reordered a little bit, right? We end up with this. So all I did was apply my multiplication property, a little bit of simplifying, bam, we have the same exact result as our cross products property. It's just a little bit faster. Rather than multiplying both sides of your equation and canceling stuff out and whatnot, you can just simply do this cross products. It's just a quicker way to solve the proportion rather than the other way. Okay, let's go ahead and move forward here. We're going to talk a little bit more about this cross products property. Anytime you write a proportion, two equal ratios like this, there are other forms that it could take that would also be true. You can kind of maneuver some of these things around, and this has to do with making sure that you set things up consistently. In the previous problem about cookies and flour, I made sure to set up my ratios so that I had flour over cookies. And I made mention that I need to make sure I did that consistently, that in the other ratio, I also had flours over cookies. Flours on top, cookies on the bottom, cookies on the bottom. It would have worked just fine if I switched these. There's no reason I couldn't have switched them. The ratios of cookies to flour and the ratio of flours to cookies, those are just reciprocals of each other, but they're still going to be equal if they are indeed proportional. So let's go ahead and talk about how we can kind of maneuver this around a little bit. Let's show that actually this is equivalent to this. It's pretty easy to make that happen. So if we take our original ratio here, and let's just say that we multiply both sides by b, and multiply both sides by d again, so that we end up with well, let's just actually do it this way. Let's assume we already believe in the cross products property, right? We already believe in the cross products. I just showed that on the last page. I was going to kind of lead up to there, but let's just skip a step here. We know that cross products are fine. This is true. Well, I can just sort of make this happen. If I just divide both sides by a, and I divide both sides by c, I can start canceling some things out here. I can cancel out a divided by a, c divided by c, and I end up with d over c equals b over a. Pretty close to what we have right there, right? Pretty close. The only thing is we just simply switch sides of the equation. So using the, that would be called the symmetric property of equality. The symmetric property of equality allows us to say that if a equals b, then b equals a. So we can just simply switch what's on each side. So we take this fraction, put it over there, put this over there. So pretty easy to demonstrate that just from our basic cross products. Let me go ahead and clear that again. Clear all drawings. All right, so let's go ahead and show this other result is also valid here. So again, let's just assume that cross products are good to go. So AD equals B times C. And then we want to arrive at this. So we want to divide this side by CD and CD. Divide by the same thing on both sides. That's the division property of equality. Let's do a little canceling. Cancel out the D's, cancel out the C's. We end up with A over C equals B over D. Bam, that's exactly what we got there. So division property of equality, so cross products, division property, simplify. Pretty basic to show that we can do that. Let's actually examine how this works with some real numbers. So let's set up a proportion, two equal ratios here. So let's say we had 1 over 2 equals, let's go 7 over 14. Hopefully we can agree that these two things are equivalent to each other. 1/2 and 7 out of 14 are the equal ratios. This property just says basically to flip these things, right? Instead of A over B, make it B over A, and instead of C over D, make it D over C. Well, let's go ahead and do that. Let's flip both of these ratios. 2 over 1 equals 14 over 7. Are these the same? Yeah, they're both the same. They're both just equal to 2. 2 divided by 1, 14 divided by 2. These are both equal to 2. So yeah, of course, these are equal. So it seems to work that way. Let's go ahead and just pick another random equivalent ratio. Let's just make something up like 4 fifths is equal to, let's multiply these by 3. So let's go 12 fifteenths. So they're equal. This simplifies to 4 fifths, so they are equal. Divide by 3, get that, right? So we have an equal relationship here. Let's examine this one. Let's kind of see what's going on here. Hopefully you notice what's happening is we're just essentially switching places here. Instead of A over B, it's A over C. And instead of C over D, it becomes B over D. So the B and the C are just switching. Let's do that. Let's just switch those and sort of see what happens. That becomes 4 over 12 equals 5 over 15. Well, is this true? Yeah, don't both of those simplify to 1/3? Let's examine that. These are both divisible by 4, so 1 over 3. And these are both divisible by 5, so 1 over 3. Yeah, equal. Seems to work. We just kind of made those fractions up randomly, so there's no reason that it doesn't work in general. And we showed how it does work for just generic letters as well. So there we go. All right, so the next section we'll be getting into is similar polygons. I'm not going to get that started right now. We'll pick that up in part 2.